this is section 7.2. It's about simplifying rational expressions. So these right here are examples of some rational expressions. These are the ones that we're going to simplify. Quotients of two polynomials. We're going to look at when can you versus when can't you cancel terms or cancel common factors. So we're going to start by doing one with numbers because it'll illustrate the principle behind what we're doing in a simple way. So if you were to reduce 27 divided by 18, you would want to look for the greatest common factor between both 27 and 18, and then you would cancel those out. So you might, just in your own words, you might say, well, you can take a 9 out of both, right? So the way a lot of students would do it is they would say 27 divided by 9 is 3, 18 divided by 9 is 2, and write it as 3/2. What I want to do is actually write it out as 9 times 3 divided by 9 times 2. Now I'm getting a little ahead here, but what I'm going to do is unmultiply two fractions. Let's write this as 9 over 9 times 3 over 3. Okay, these are equivalent because when you multiply fractions, you multiply across numerators and you multiply across denominators. Well, 9 divided by 9 equals 1. So those 9's cancel, and we're left with just 3/2. I wrote it out this way because this is the way that's easiest to write it when you have variables and x's involved. So when can you cancel versus when can't you? Well, everything has to be factored because you have to essentially be able to pull off a common factor the way I did this. Okay, now I don't usually actually write it out as a separate fraction. Usually I would just cancel at this step right there. Okay, so right here is a great example. You have 5 times x plus 2 over x plus 3 times x plus 2. Now because both the numerator and denominator are both fully factored, yeah, there's some plus signs, but they're inside factors. So those two factors of x plus 2 do cancel because you could pull them out as a separate factor, which is equivalent to multiplying by 1. Now here, the x plus 2's do not cancel, and that's because of this plus sign right here, because this numerator is not factored. Everything, both the numerator and denominator, have to be fully factored before you can cancel anything at all. In this case, you would actually simplify the numerator by adding the 5 and the 2. That one's equal to x plus 7 over the product of x plus 3 and x plus 2. And you don't have any common factors there. Yeah, there's an x and there's an x, but they don't cancel because you have a plus here, right? It's not fully factored. Okay, so let's start with a simple example. 40x cubed divided by 12x. Between the 40 and the 12, let's see, we could divide them both by 2 at least, maybe something more. So let's write it as 2 times 20, that's the 40. The 12, let's write it as 2 times 6. Now the x cubed and the x, I've got 3 x's divided by 1x, so one of the x's cancels, and that's just going to leave me with x squared. And I pulled a 2 out. Now I'm looking at these numbers to see if they reduce further, and I don't think so. So you might see this written as 20x squared divided by 6. You might also see it as, oh, what am I saying? You could take another 2 out of both of those. Write that as a 10 and write that as a 3. So you could write it like this, 10x squared over 3, or you might see it as 10/3 times x squared. Either way, those are both good answers for a simplified version of this rational expression. Okay, here's another rational expression, a plus 5 times a plus 7, all divided by a minus 2 times a plus 5. Everything is fully factored. Now, they're not in order, but the a plus 5's do cancel because it's fully factored. So this reduces to a plus 7 divided by a minus 2. Notice the a's do not cancel because this numerator, there's no common factors. You've got a plus here, you've got a minus here. So no common factors between the numerator and denominator there. Okay, now this one is not factored. We've got a plus, a minus, a plus. So at this point, I can't tell if it's going to simplify or not just from looking at it. We have to actually factor it and see, or attempt to factor it and see. So let's try factoring the numerator. It's a trinomial quadratic, so if it factors, it's going to factor into a product of two binomials, both starting with an h. And let's see, 16 breaks down into 8 and 2. That's good. I can get a 6 out of 8 and 2 if I do plus 8 and minus 2. Now the denominator, if it factors, it will also factor into h. We need the middle term to be negative and the last term to be positive. So they're both going to have a minus, and if we do 2, that should work. That'll get us a negative 4h for the middle term and positive 4 for the last terms. Okay, now it is fully factored, and we have an h minus 2 both on top and bottom. So this one reduces to h plus 8 over h minus 2. Okay, so you need to pause the video, try the next one on your own. Notice it is not factored. Oops, I think I have a typo in that one. Let me check. Yeah, that's a complete typo there. I meant to put 2 separate problems, but combined into one. Okay, so it should have said a minus 2 plus 8 all divided by a minus 2 times a minus 5. Now the question is, can we cancel the a minus 2's? Well, no, because the numerator isn't factored. There's a plus 8 here. So first, let's simplify the numerator. Let's see, the negative 2 plus 8 is negative 6. And yeah, it looks like there are no common factors, so that one does not reduce any further. Let's see. Yeah, this next one, let's just go to this one. This next one here, these 2 factors look alike, but they're not exactly alike. We have 3 times x minus 4 divided by 5 times 4 minus x. So they both have a minus, but the terms are backwards, x minus 4 and 4 minus x. So the trick is, in one like this, is to factor out a negative 1 from either the numerator or the denominator, not both. It's numerator or denominator. So if we factor out a negative 1, let's say from x minus 4, I'll just take it out of the numerator. I'm going to put that out in front of the 3. Then the negative, this was positive x, so it would become negative x, and then minus 4 would become positive 4. You can check by redistributing the negative, you would get plus x minus 4. Then in the denominator, we have 5 times 4 minus x. Now, order of addition doesn't matter, so I'm going to flip around those 2 terms, the negative x plus 4, and write that as 4 minus x. And notice now they look alike. 4 minus x over 4 minus x, they do cancel. And so this one reduces to negative 3 over 5. So that's a nice little trick to remember. If you have 2 factors that are almost the same, they both have to have minuses, but the terms are backwards. Just factor out a negative 1 from either the numerator or denominator. That will make them look the same, and then they'll go ahead and cancel. Now I want to show you one last special example, and that is how to do it, or how to simplify, another way to simplify it, if you were dividing by a monomial, meaning one term. This does not work if you have 2 terms in the denominator like you would here, or 3 terms like you do there. This only works if you have 1 term. And that is, you could alternately, instead of factoring, although you could factor this, at least you could take 1x out of everything, but alternately you could split it into multiple fractions. So what I'm going to do is keep the denominator the same on all 3 fractions, because when you add and subtract fractions, the denominator stays the same. So I am unadding these 3 fractions, pulling them apart, and then you can reduce each of those fractions one at a time. 14 over 2 is 7, x to the 5th over x squared is x cubed, minus 11x, and then one of these x's cancels, so you get plus 9 over 2x. So that's another way to look at it. I think you should just be exposed to that method right there. That's it for section 7.2.